directly from SAPO Labs. We are going to continue with our event, and we are going to have Jorge Teixeira. Round of applause.
So thank you for this invitation. I'd like to thank the organization of the event for inviting me here. My name is Jorge. I work at the SAPO Labs. I'm coordinating the R&D projects currently that are happening there. And I'm going to talk to you about text mining. What is text mining? If text mining actually matter, if we do anything with it. And I'm going to present you some use cases that we have at SAPO to prove that text mining is relevant in our everyday life. Hopefully almost all of you know SAPO, but I'll tell you what is SAPO. How was SAPO almost 20 years ago? What is SAPO now? I'll talk to you about SAPO Labs. And then I'll talk to you about text mining, some brief definition of text mining, and I will actually examples of text mining work at SAPO. So, 20 years ago, SAPO was something like what you can see on your left side, a black and white website that were like an aggregator of pointers for the most important links that were around the Portuguese web. And also, of course, search engine. Okay. Some years later, SAPO just got some colors, as you can see on the right side of the screen, and now it's a completely different platform. It's responsive, so you have all the support on web and desktops, on mobiles, on tablets, on TV, IPTV platforms. So it's all around us, and with a completely different aim. So first, we are a hub of curated content. Curated in the sense that our content has to be good or excellent for our users. We are talking about news, opinion articles, blogs, and so on. And another important infrastructure that we have is e-commerce. So you may know several of these services, like SAPO, which is where you can sell or buy your a car. The same for houses, vouchers, restaurants, and other kind of e-commerce services. We also have, we provide platforms like email, which is one of the oldest email platforms in Portugal, blogs, videos, maps, and so on. We are the Mail Innovation Factory. So if you have mail at your place, using your IPTV set-top box, you probably are going to use a lot of code, a lot of applications developed by SAPO, other things like wallets, cloud, and so on. SAPO Labs, probably just a few of you know. Who knows SAPO Labs? Whoa! Okay, that's awesome. SAPO Labs is started as a partnership between the universities and the academic world and the industry. And the goal is to bring these synergies together and to put the excellent research work that is done in the university and bring it together with all the technological backbones that we have at the industry. And that's the purpose of SAPO Labs. We have some projects, some R&D projects going on, which aim to bring this research stuff into the industry and do interesting things with that so that end users, SAPO users, can benefit from this research. So we have two laboratories, one here in Porto and another one in Aveiro, and they have also a large network of academic partners all over Portugal. So this is SAPO and SAPO Labs. What about text mining? I'm going to present you 3 definitions of text mining, and I hope that you can understand it. The first one, of course, is extracted from Wikipedia. And it states that text mining refers to the process of deriving high-quality information from text. So, deriving high-quality information, that's the first thing, and from text, that's the second thing. So, we look at text, we can look at documents, blogs, social media posts, books, poems, whatever we want. It has to be text, and we try to extract knowledge from it. And the information that we extract has to be high quality, or ideally should be high quality information. The second definition states that text mining is the process of discovering and extracting knowledge from unstructured data. So we have to discover that knowledge, but we also have to extract it. It's not the same thing. One thing is, okay, there is a person's name on that text, and the second thing is how can we extract it, okay? And on unstructured data, so we're not dealing with databases where everything is correctly stored. We are looking at completely unstructured data, which can be HTML, which is the most common kind of data that we use on the web. And finally, text mining is the discovery by computer. And this is something that's on the previous definitions we didn't find, is that text mining aims to be done by computers, it's not by humans. So we expect to perform whatever you want on text automatically. And we expect to extract new unknown information and possibly link that information between each other to achieve new facts, new knowledge. Okay? So this is more or less how can we define text mining? Sorry. There are a large set of tools that you can use to work with text mining. Some of them are open source tools, others are premium tools. One of the most interesting ones is scikit-learn. It's a Python framework that you can use to do a large set of text mining and data mining and machine learning tools with Python, which is a quite friendly language. And then you have many other tools like tools for R, for RapidMiner and Natural Language Toolkit and so on. The last ones, OpenCalais and Alchemy API, are two premium tools in the sense that you can access the APIs for free, but you have limited number of access. And with these APIs, what you usually can do is that you can give a certain text, for instance, a news article, and it returns that news article with a set of enriched information, like names mentioned, organizations, locations, classification of the document, if it's about sport or if it's about politics, sentiment analysis on the top of that. So all text mining things that I will describe in a moment that you can do on text and you can achieve by calling some APIs. So this is just a brief overview of some of the text mining tools that you can use. But does it really matter in the sense that we can do a lot of interesting things, but most of the times these are just for geeks or just for a small group of scientists that are in the lab doing interesting stuff, but no one will ever use it, no one will ever see them doing useful stuff. Here are some examples of applications of text mining on the web, and I'm focusing on the web because that's the core business of SAPO, okay? So we can extract entities from unstructured data. What do I mean by this? If we look at a HTML web page, for instance, we can identify names of people, names of organizations, names of locations, other type of structures like timestamps, a lot of things that we can use, for instance, for markup or for search. Let's say that we are reading a blog about Facebook and somewhere in the post you have a mention to Mark Zuckerberg. You hover your mouse over Mark Zuckerberg and somehow there is a pop-up window with a photo of Mark Zuckerberg with his description, the company, his net worth and so on. So this kind of information is interesting, but first we need to identify those entities. We need to identify relations between those entities. Knowledge graph from Google, as Matthew presented, briefly described in the morning. For instance, if you look for Cavaco Silva, you probably have Pedro Passos Coelho as a related entity. And that information you can see on knowledge graph from Google if you search on Google web interface. This is the kind of information that it's quite useful to understand why people is together, in what sense they are present on the web in the same documents. You can visualize information. This is quite interesting because nowadays people tend to avoid reading a lot and they prefer that information is given with pictures, with images. for infographics, which is nowadays very common. Everything that you read on a newspaper, if you go, for instance, for Guardian, one of the examples that I put here, Guardian, you have a specific section of Guardian just regarding infographics and data that you can use to perform, for instance, text mining approaches on that. Another example is analytics. If you are looking for the logs of your website and you are analyzing how many users access it to try to predict the number of users that are going to access your site on a Saturday morning or on a Saturday evening, to understand if you have to connect more, to turn on more or less servers. All this kind of information is important. It can be processed with text mining and should be visualized in a very proper way. I'll show you in a moment some of the challenges of this visualization. Then we have sentiment analysis. Social media and e-commerce are two important topics for sentiment analysis. For instance, if we are talking about politics, politicians are always aware and concerned about what people think about them, especially in elections. They are always looking at social media and try to see if people are saying good things or bad things about them. And if you move from politicians to companies like Mail, for instance, where I work, from SAPO, if Mail releases a new product, there is certainly people going to be tweeting and posting Facebook messages about that product. And it's important to understand if they are saying good or bad things about the product. That's sentiment analysis, and that's clearly performed with text mining techniques. So another example why text mining actually matters. Recommendation. You have news articles, you read one news, and immediately the platform that you are using is going to recommend you several other news articles related to that. And that recommendation a few years ago was very naive, only based on probably the section. If you are reading something about sports, I'm going to provide you another thing about sports. Nowadays it's more intelligent and topics can be more fine-grained. Recommendation can also have can use the context of the user, our previous history, and so on. And finally, and this is just few examples of application. You have classification and similarity. If you are using a newsreader like Flipboard or Zeit or things like that, your information is clearly organized. So you have things about iPhone, you have news about iPhones, you have news about Android, you have news about different topics, and everything is clearly well classified. And probably these platforms try to aggregate similar content, so you don't have to read the same news article published by different industries over and over again. So what I presented here is just what you can look for through the web and see implications on the text mining issue. Oops, sorry. Some of the challenges with this text mining area can be, for instance, how can we present this information to users? Here we have two examples of two beautiful visualizations of data. But the thing is that we can't extract anything from here, at least in the first 10 or 15 seconds. I look at this, okay, this is a beautiful rainbow probably, but what else? And here we have a network of Twitter users and their connection between each other, but there is no knowledge that we can extract from it immediately. And if we cannot do this, we cannot certainly use one of these kind of visualizations and put it, for instance, on SAPO. So I was trying to tell you that we need to be careful how to use text mining for the end users. And in the SAPO particular use case, we have to be sure that these kind of things don't happen, because users will not understand what's going on here, and this will not be informative, and we'll lose 90% of the users that are coming to our portal. So finally, I don't know how much time I still have, but oh no. I'll present you some a bit different use cases. So in this slide, I present you the typical text mining applications that you can see, and I'll just go over again. So because this thing about the air, it's getting confused. So extract entities. We look at the text and we try to extract names of people, names of organizations, and of locations, wherever, and we can mark up things. We can identify relations between organizations. I can say Mark Zuckerberg is CEO of Facebook. There's a connection, which is CEO. We visualize information. We can extract sentiments from documents in order to predict if the sellings of a particular product are going well or not. We can recommend content, like I gave you the example of news articles, but we can buy a product at eBay, and eBay will recommend me to buy another set of products that are similar to my needs. And we can classify documents and find similarity between documents, and this will enhance our user experience while reading, for instance, news articles. Okay? What I'm going to present you here are 4 use cases that we develop at SAPO Labs, some of them together with the University of Porto here, supported of course on text mining approaches. The first one is called Máquina do Tempo. The idea is that we have a large data set of news articles. We have about 9 million news articles from Portuguese sources, published between 1987 and today. So we have news from a time span of almost 25 years. What can we do with this kind of information? We cannot just give it to the users as a typical repository, because people is not going to use a search box to extract knowledge from that. That's not going to happen. So I can only talk for 5 minutes, right? Then we need a break every 5 minutes. That's the challenge. And the idea is to look at all that kind of information and try to extract knowledge from that. So that was the primary definition of text mining. And we do that in 3 different ways. First, we try to extract entities, names of people that are occurring on news articles. So every time that we read a news article, we try to identify all names of people that are mentioned there from 1987 until today. Then we try to establish relations between these people. If they co-occur on the same news article, we assume that they have a connection and they represent something meaningful between them. And finally, we try to extract some short biographies from these personalities based on information that journalists gave us. What can I say about in the first slide, in the first image, sorry, we can see a profile page from our Prime Minister, Pedro Passos Coelho. So, of course, all this was extracted automatically. That's the purpose of text mining. What you can see here, it's a set of news articles where Pedro Passos Coelho was mentioned. So the first part, we extract entities from news. We also extract quotations from news. Quotations are direct speech, usually between quotes that people state about something. They are very informative and actually contradictory. So it's interesting to look at quotations from politicians today and 2 or 3 years ago, and state that they clearly were saying different things before and after the elections, for instance. And on this last column, we can see connections between people, which are presented on this second window here. So here we have Pedro Passos Coelho, Paulo Portas, and António Costa. This is clearly a strong connection between them, because the first 2 are from our government and the second one is the opposition. And what we can see from this graph is that there are a lot of other connections from probably from people that we are not expecting to be connected to the Prime Minister. And the interesting thing about these graph knowledges, if I can call them that, is that you can explore this information, click on people, try to understand news that make them together, what events bring them together, and navigating through time. So we can look at a window of 1 month, 2 months, 1 year, 20 years, and you can see, we can sum up, for instance, the relationship between Pedro Passos Coelho and other politicians for the 2014. Okay? But although this is interesting, SAPO was expecting something more simpler, because they thought particularly these networks were still a bit complex, because people looked at them and they sometimes could not extract new knowledge immediately. So we lost something quite simple, just a top of people that are mentioned on news. So based on the information we extract from news, namely the name of people, we created a top for news about sports. So we classified all news that were classified. It's smelling smoke here. Should I be worried? Okay. So this is an example of the top, the most mentioned people about in sports news in the last 3 days. Okay. We have Jorge Jesus, which is ex-coach from Benfica. So the last part that I mentioned you, we try to make some short bios from people that we identify on news. And the ex-coach of Benfica is today, but if we move to news from 2 or 3 months ago, we could see that he was coach of Benfica, and if we could move backwards, we could create a short profile from this person. Some R&D areas involved in the project. We have, of course, text mining. On top of text mining, we typically have machine learning techniques so that we can do this in a supervised way, in the sense that I give a few examples to the system learns, and then it works for itself. I don't need I don't need to say anything else for the system. For example, I was mentioning here that these people were mentioned on news about sports. How can I say those news are about sports? I just have a bunch of news that I certainly know that are from sports. I give it to my machine learning system, who will learn. And whenever I have a new news article, I'll present it to the system, and the system will try to figure if it's sports or not. Okay? So that's the purpose. Some information extraction and natural language processing, for instance, for the quotation extraction. Some backend technologies, so Perl and Python were the backend programming languages. Databases, we have both kind of databases, both relational databases like MySQL and non-relational databases. REST and SOAP for web services, and then more low-level things like crawling, caching. I think someone in the room mentioned the memcached, so one of the things that we use. Some front-end technologies. This is the trivial ones: HTML, CSS, JavaScript, jQuery, and then we use D3.js and Sigma to create those networks that are static over there, but if you go to the link, you can see they are constantly moving and they are forming clusters of people in real time. The second project, it's called Popstar, sorry, and it stands for Public Opinion and Sentiment Tracking, Analysis and Research. And the goal here is to look, track information that is published on social media, news, blogs and Twitter, and try somehow to correlate that with public opinion that we can find from pools, traditional pools that are made, for instance, by phone. If we focus on the politics domain, we have institutions like Católica that make several calls to people from a broad spectrum of ages and qualifications and so on, and they say, oh, the left party is going to have 35% in the next elections, and the right one is going to have what you try to do to correlate that with two things. First, the popularity of the candidates on this social media, on news, blogs, and Twitter. So basically we make some kind of counts of the number of times those persons were mentioned on these sources of information, and we analyze the variation of that noise, of that buzz, a long time. And the second thing is sentiment analysis. Sorry. We look at those messages, and sentiment analysis is only performed on Twitter messages. We look for those messages and we try to see if Twitter users are saying good or bad things about politicians. And they try to somehow evaluate the evolution of that sentiment a long time and see if there is any kind of correlation between that is extracted on social media and the information from pools made by phone, for instance. Okay? So we use R&D areas include, of course, text mining and a bit more broad data mining, sentiment analysis, and some other areas. Backbone technology included here scikit-learn, one of the text mining tools that I mentioned you before, which is quite good for machine learning approaches. And some other technologies like REST API, Social Buzz, and so on. The last two projects are quite similar from the backend perspective, but they have different application scenarios. The first one, it's focused on quotations from Fernando Pessoa, a Portuguese writer. And the idea is to understand if Fernando Pessoa was still or is mentioned on social networks. And the fact is that on the last month we identified more than 200 quotations from poems from Fernando Pessoa on Twitter and Facebook. And this is quite interesting, and that's the purpose of this project, to identify quotes of this author on the social networks and try to aggregate them and put them on a kind of a dashboard. It's tops. And for instance, here we can say that Tabacaria is the most commented or the most quoted poem from Fernando Pessoa on the social networks from the last month. Okay? So again, this is another example, not a trivial example of text mining applied on the web, but a different one, which is still interesting. And of course, it's on the top of the web and using web data. The last one. It's about music. So again, the backbone is similar, but instead of looking for quotes from Fernando Pessoa, we are looking from titles of musics and match those titles of musics with albums and with music styles. And we can see interesting things. We don't have enough detail here, but if you go to this website, reggae, for instance, is more popular on the summer than on the winter. And electronic music is going to be much more popular in the winter than on the summer. And you can extract that kind of knowledge by looking at these graphs. And this ends my presentation. Sorry for these interruptions, but it was not my fault.